Geloso G110, 1952–1956. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. In the 1950s, Italy experienced an economic boom, and Geloso was leading the electronic market, advertising more the brand than the single products. This radio was produced between 1952 and 1956, and its technical details are documented in the Geloso Bulletin 55, summer 1953. It appears also in the A&IE Catalog 1955. This radio was in the lower end of the Geloso products, but still at a price that could have been higher than a half of a monthly salary of a public employee or professional. The front knobs are removed. The screws are covered by an insulating plaster because the radio chassis is connected to the mains, and touching it by chance would be lethal, even through the hidden screws in the knobs. Therefore, in this case, removing the knobs requires some effort. Once the front knobs are successfully removed, the rear cover is opened. The white screws are not the original ones. They had been replaced with nylon screws to avoid getting in contact with the internal chassis. On the rear cover there is an extra knob and a small switch. They are not part of the original device, and they will be removed during the restoration. The original radio configuration allowed to select the supply voltage, but in this case it was already modified to a fixed 220 volts to avoid dangerous mistakes. Therefore, the selection jumper is also missing. During the restoration, this precaution measure will be kept. Before extracting the chassis, there is still a knob to remove, the one on the side connected to the band selector switch. An additional circuit was added to this radio, a BFO, with the purpose of listening to SSB communications. All the extra components are removed, starting from the additional potentiometer and switch. The main BFO circuit was shielded inside a small tin box and powered by the line used for the light of the dial. Also, the corresponding light bulb socket is missing. The chassis is finally extracted. Before proceeding any further, the vacuum tubes should be removed and put in a safe place. Each one is packed separately, and the name is written outside. The cabinet is separated completely and then dismantled. It will be cleaned and recomposed later. Before removing the connection with the BFO circuit, it might be useful to understand how it was actually connected. The tin case must be opened. The circuit appears to be a variant of a project published in an old Italian electronic magazine, with the addition of a voltage regulator and of a double varactor diode to tune to the intermediate frequency. To introduce the BFO signal, the radio was modified, as highlighted in red in the schematic diagram. The BFO is finally removed, and the original radio circuitry is restored, although only temporarily in this phase of the restoration. The orange wire that was connected to the BFO circuit was the source for the 6 volts AC originally meant for the dial light. That wire, like the others coming from the transformer, was insulated with rubber, which now has become rigid and is broken in many places. Therefore, all the transformer wires should be checked carefully and then replaced or insulated properly. Usually, factory radio schematics were drawn with the purpose of having them compact, often making them difficult to interpret. It is also necessary to consider that an official schematic diagram might be slightly different from the reality of a radio under restoration. Before proceeding any further, it would be important to prepare a schematic diagram that one could understand easily with confidence, following the personal inclination regarding the way that such schematics should actually be drawn. It would also be the case to prepare a drawing of what is under the chassis, because the actual position of some components could make the difference. This process represents an investment for any subsequent intervention, especially if it is necessary to disassemble and then reassemble the radio. The labels appearing in various parts of the radio, including the components, contain important information regarding the story of that particular item. Before cleaning and before replacing components, if there is no plan on keeping them, it would be appropriate to prepare some replica labels which at least resemble the originals. Such labels could be used later or simply made available to others, restoring similar items. This radio is very compact and it is very difficult to reach the components that are located in the lower levels. It has taken the decision to dismantle everything, so that also the chassis could be cleaned and properly protected from rust. Only the RF and the IF modules will remain internally untouched. To remove the power transformer and the IF transformers, a more powerful soldering iron is necessary. It is important to remember that the IF transformers may be different, so before removing them, it is necessary to do something to distinguish them later. After failing the attempt of cleaning thoroughly the chassis with the tube sockets still on it, they are also removed carefully. Before reinstalling the components, they should be checked and prepared. The capacitors that are in good condition seem to have kept reasonable insulation, so they will be reinstalled, at least for now. Later, except for the mica capacitors, they will all be replaced. The problem of this compact radio is the isolation between the components. Before reinstalling them, they will be prepared to avoid shorts. In particular, the small mica capacitors have lost the external coating and some heat shrink pipe is used to provide better insulation. However, it turned out later that shrink pipes are harder than the capacitors, which might bend and also break them. The power transformer requires particular care, especially considering that it could be hardly replaced. The original transformer's wires are losing their insulation completely. In fact, about 40 years earlier, some wires of the transformer were already replaced or better insulated. However, insulating the wires is not sufficient, and later, also some hot glue is used to better prevent short circuits. The tube sockets are installed using regular small screws and nuts, but the screws are inserted inside out so that nothing would protrude under the chassis. Then, the chassis ground line should be connected carefully so that these wires would remain at the lower level near the internal chassis surface. After that, there are the heaters or filaments, and from now on, everything should be carefully insulated. Even the terminals of the tube sockets should be insulated because the space separating them from the chassis is extremely small. Then the IF and power transformers are installed and progressively connected, always with care for the insulation. Also, a fuse holder is installed in a place that seems to be safe. However, later it will have to be moved from that place. The radio is prepared for connecting to the mains and also to the external ground because it will be tested with an isolation transformer. Later, this ground connection will have to be removed because this is a hot chassis radio. After completing the connection of the power transformer, it is appropriate to verify the voltages provided before installing more components on top. The values read with the multimeter are higher than specified in the original schematics, but at the moment there is no load at all and a significant drop is expected after the radio is completely rebuilt. A small 3-pin DIN connector is added for the loudspeaker. The chassis is slowly repopulated with all its components. The vacuum tubes are mounted too, and the voltages provided by the power transformer are tested again. Now they are close to the expected values. Luckily, no mistake has been made in rebuilding the chassis. It is already working, although it requires some alignment. The next step is the dial and its tuning cord. It is important to verify that the dial pointer moves according to what is printed on the dial glass. The power transformer is supposed to provide an output of 6 volts for the dial light, but the real voltage oscillates between 8 and 12 volts. Instead of a regular filament light bulb, a 12 volts LED light bulb is added after verifying that it works correctly with that voltage fluctuation. Everything is now prepared for putting the chassis inside the radio cabinet. In particular, the external ground connection is separated from the chassis. The loudspeaker is separated from its plastic grill by a thin iron net, which already has some rust stains. A piece of cloth is put in between the grill and the stained iron net for aesthetic reasons. Finally, the chassis is put back in the radio cabinet, but it is necessary to add extra insulation to avoid the possibility of touching the chassis inadvertently while operating the radio. This was my first restoration, after 45 years, with very basic equipment. Only when I was a young kid did I fix old radios and televisions with just a soldering iron and an analog multimeter, then nothing for a very long time. At this point, the performance of this radio is not so exciting, but at least it works, and the restoration will be revised 1 year later. Ad esempio dalle partenze, dalle ferie, ecco perché abbiamo cercato di creare anche delle linee dedicate.
Prefektúra honlapját a világhálón. Az ottani forumon sokan jelzik, hogy szívesen ellátogatnának a városba. Nem rossz város.
1 year later. This radio has been the first restoration project of this series, originally done with the purpose of keeping as many factory components as possible. The purpose of these projects changed to bring radios to some safer operational condition, with all dubious components replaced if possible. In particular, this radio is now becoming a gift to a person who is willing to use it, and a little more care to safety is definitely in order. The original or old capacitors are now replaced. There is more space now under the chassis, and a solder tag strip is added to rearrange the power cord connection. The input power voltage selector was already not used from the original restoration. That space is now perfect for placing the fuse holder and an antenna socket. For the antenna socket, an audio connector is used just because it has an insulated body, while there would not be enough space for placing a BNC connector, isolating it from the chassis. With a plate coming from a tin can, a small piece that would replace the former input power selector is cut, adding the holes for the fuse holder and for the antenna socket. The components are installed and properly wired. In particular, the radio will be used in the US, therefore a spade power plug is used, connecting the chassis to the neutral side of the plug. The power switch is now inserted before the hot power line, but after the fuse. The volume potentiometer and power switch is inspected and cleaned. All the shafts are very short, and at the factory they have not been prepared to receive the knobs properly. They would easily come off or just lose the grip. The shafts are then filed to prepare the appropriate seat for the knob set screws. The LED pilot lamp seems to be working correctly without generating noise. However, as an extra precaution, a safety capacitor is added in parallel as a filter. Some clear plastic, cut from a small grocery basket, is used to insulate the chassis areas that otherwise might be accessible from outside the radio cabinet. In the end, all the tubes are replaced with new ones. The plastic cabinet is repainted. The front knobs, which were already not original, are replaced with new ones, and the knob set screws are covered with some insulating material. This radio has been blonde for almost 70 years. It is now black and hopefully will live for 70 more years. My friend Paige accepted my gift. She was also happy to let me take some funny shots with her new puppy radio.